Did a few videos on DMR this last year, so I guess that sort of qualifies me as an expert on the mode. I'm not quite too sure about that. Hi, I'm Michael, KB9VBR, your host for Ham Radio Q&A. I'm on a mission to inspire and educate the amateur radio community, so if this is your first time watching, please consider hitting that subscribe button. Well, I recently did a presentation at a local amateur radio club about DMR, or digital mobile radio. This presentation on DMR was recorded on Wednesday, March 13th, 2019 at the Vilas County Amateur Radio Club in Eagle River, Wisconsin. The video is slightly edited for time and content, but please feel free to use it at your local ham radio club meeting if you're looking for a topic such as an introduction to DMR. And if you have any questions about DMR or comments about the presentation, please leave them below. I'd be glad to hear them. But first, let's get into the introduction to DMR presentation. So I'll just kind of get into the presentation. If there's any, the presentation's not overly long. It's not overly technical. I tried not to keep it. I didn't want to get into the weeds. But if there's any questions, feel free to break in with your questions, and I'll be glad to answer them. And I'm sure we'll have plenty of time afterwards that we can kind of talk more about DMR or digital mobile radio. So I'm guessing that question number one is, what is DMR? So basically, DMR, it is an ETSI published worldwide standard. And don't ask me what ETSI means because I forgot to look it up.
It's a European standard.
Yeah, DMR actually came. DMR is a consortium out of Motorola, Hytera, and then there was a European company, and I forget what that company's name is. It uses a type of it's not really modulation, but it uses a mode called TDMA, which is time division multiple access, and that's really a differentiation between some of the other digital modes we see out in the amateur radio community, like D-Star or System Fusion. We'll talk a little bit more about that in a bit. It uses a digital codec called AMBI +2. So it's a very sophisticated digital codec, gives you a very high quality digital audio, and also it supports data applications. Many you can also text, potentially email. A lot of these DMR radios have built-in GPS units, and that data stream can also be transmitted along with voice. So, moving on, why do we want to move? Why would we be interested in DMR, or why DMR for the amateur radio community? Well, like I said, because it was created by a consortium with Motorola and others, DMR has become a commercial radio industry standard, much like P25 is a standard among law enforcement and public safety. DMR kind of holds that same kind of cachet. You'll find there are a few public safety agencies that are using DMR. Land mobile, radios, services are using DMR. It's an open standard, so it's almost any radio manufacturer can license the DMR technology and start producing their radio. And that's why you see so many inexpensive DMR radios out there, because it's an open standard. The Chinese just kind of glom onto that and start pushing out cheap DMR radios. It's spectrally efficient. The DMR, the radio signal only takes 12.5 kilohertz of bandwidth, so it's a very, very efficient mode of modulation. It has that AMBI +2 codec is very efficient. It produces high quality digital audio. It also has a high tolerance for bit errors. So there's error correction and redundancy in there in order to keep the errors down very low. Like I said, it's wide support by quite a few radio vendors. You can, I don't know, kick a cat and you'll probably find a half a dozen different, Chinese DMR radios out there. I got a few out here on the table, and we can talk about those too. And really, the neat thing about DMR is it's two repeat. When you put up a DMR repeater, you get two repeaters in one. Because of that TDMA, or time division multiple access, you've got two separate channels. So there can be two separate conversations, digital conversations, going on that DMR repeater at the same time. DMR is broken down. The specification is broken down into tiers, and the first of that basic tier is tier 1, and that's called one slot DMA. Like I said, you can have two simultaneous conversations going on that DMR stream at the same time. Tier 1 radios can only do one conversation at a time on that radio stream, and that's going to be important, to differentiate, when we move into those other tiers. So you're really going to find a tier 1 radio is only suitable for simplex only, because it can only use one of those slots, those time slots at the same time. Moving on, tier 2, that's known as the 2-slot TDMA, and the tier 2 radios are the ones that are actually most used in the amateur radio community. So if you're looking to buy a DMR radio, you're going to want one that is a tier 2 radio. It'll work for both repeaters and simplex, and it has that ability, to send. And tier 2 repeaters can be connected, via the internet to create your DMR network. Moving on, tier 3, that too is a 2-slot DMR system, but it adds the advantage of trunking, or multi-channel, multi-site. And also a neat thing that tier 3 radios can do is sort of like a DMR follow me. If you've got a network of DMR repeaters, the tier 3 radio will pull the repeaters and find the one that's closest and it's got the best audio, the best signal path, so that you can stay within a certain talk group, and the radio has enough intelligence to kind of keep you connected as you travel along on a tier 3 system. That hasn't been implemented yet in the amateur radio community. So, but that's something that's more important as you move on into the commercial radio. And as I said, DMR, 2 channels, 1 frequency. So because it's time division multiple access, the signal, if you think about this, the signal as it emanates from the repeater is split into chunks. And each little chunk is 60 milliseconds long, or each pair is 60 milliseconds long, or 2 30 millisecond time slots. So it's going AB, 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 one right after the other on that constant stream. And then the DMR radios decode that and then turn that into 2 separate voice channels. Does that kind of make sense?
Yeah, Michael, the whole channel is 12.5 kilohertz.
Yes, it is.
And there's two conversations going on. So what you were asking, Roger, is it's not 24 and a half.
It is 12
It's 12 and a half, period.
Yep.
And there's 2 servers being served in the 12 and a half.
That is correct. Yeah. It's kind of, when you kind of hard to wrap your head around it until you sort of visualize, how it's sort of slicing up that time domain. But still, with 12 and a half kilohertz, we've got half the bandwidth of an analog signal, so it's very spectrally efficient. You could ideally put 2 DMR repeaters in the same space as one additional analog or one analog repeater. Neat thing about DMR is it doesn't need, that signal doesn't need the guard band protections along the edge, so you can really stack those up in a section of spectrum. Just talking a little bit about the bandwidth. FM wideband, see if you can kind of visualize how much space that would take up spectrum-wise. FM narrowband, which is 12.5 kilohertz. D-Star, which is a single 6.25 kilohertz signal. And then DMR still uses that same amount of bandwidth as FM narrowband, but because of the time slicing, can fit 2 channels. Technically, D-Star could be able to fit 2 channels. You know, they'd be 2 6.5 kilohertz channels within that 6.125 kilohertz channels within that 12.5 kilohertz chunk of spectrum. So don't ask me which one, which method is better, D-Star or DMR. Some people say the audio is better on one than the other and whatnot. This is just another graph that just kind of illustrates the difference between FDMA, which is frequency frequency division multiple access, and TDMA, which is time division multiple access. You see, with like Fusion or D-Star, we would fit 2 signals into that 12.5 kilohertz channel, whereas with DMR, we would fit 1 signal split into 2. So you get more bandwidth. You could technically have a better audio quality because we've got more bandwidth, but because we're slicing our time in half, that lowers our data stream. So when you do the math, the data stream bit rate on DMR is pretty close to the same data stream bit rate as you find with D-Star or System Fusion. So your end result is that the audio quality sounds pretty much the same between the three different digital modes. A little bit, one thing with DMR is because this comes from the commercial radio world, we've got some terminology here that's a little bit different than what we're kind of used to in the amateur radio field. So you hear things like, if you start exploring DMR, you hear things like, DMR IDs, talk groups, time slots, code plugs. What do all these mean? Basically, your DMR ID it's a number that identifies you as a unique user on the DMR network. With System Fusion, when you first get your radio, what's the first thing you do? You plug in your call sign, and then that identifies your radio as a particular device. And I think you do the same thing with D-Star. I'm more familiar with Fusion.
You have to register.
You got to register it, and you get your ID number. Well, you do the same thing with DMR. You register your call sign, so you get an ID number. Now the thing is that in most cases the person only needs one ID. So if you've got multiple radios, they all can have that same DMR ID associated with it. The only time you would really need 2 DMR IDs is if you were going to use 2 radios simultaneously, and you wanted to be able to show the difference between the two. But one DMR ID per person is sufficient, even if you've got a half a dozen radios. And to get that DMR ID, you go to radioid.net, and then you just fill out a little form, and that's it. So if you're planning to purchase a DMR radio, when you place the order for that radio, go to radioid.net and get your DMR ID, and because it usually takes a day or 2. So then when the radio arrives, you've got your ID in hand. You can plug in that ID number, and you're good to go. Now the thing to consider though is your DMR ID is not your method of identification for purposes of the FCC. So even though if you've got your radio programmed so that when you transmit, your ID number shows up on the radio and potentially your call sign on the radio that's receiving your signal, you still need to identify with your call sign over the voice channel, because your call sign is not being transmitted on the DMR data stream, only your DMR ID number. So that makes sense?
Yeah.
Yeah, okay. Talk groups. Talk groups are as a method of organizing your DMR traffic. Like I said, these systems can be networked, so you can have a lot of people communicating, and you're going to want to kind of segregate communications. So you can create a talk group, and the talk group is an analog for system fusion rooms or D-star reflectors. Basically, talk groups exist, and there's talk groups that exist for entire countries, states, regions, cities, special interests. There's like there's a Maker talk group, there's a Raspberry Pi talk group, there's a Skywarn talk group, there's Wisconsin talk group, there's a Midwest talk group, and then of course the entire North America talk group. Time slots. We talked a little bit about time slots a bit. With your TDMA method of splitting your signal into two voice streams, each voice stream is referenced as a time slot. So your first voice channel is time slot 1, and your second one is time slot number 2. DMR repeater can handle 2 simultaneous conversations, one on time slot 1 and one on time slot 2. And then what will happen is the repeater, will assign different talk groups, various talk groups to the different time slots on the repeater. So if you come up, say you come up to a repeater, you might find that all the local traffic might be on time slot 1, and then if you go to time slot 2, you might find that one might have a talk group full time for regional traffic. Color codes. When you start to program your radio, there'll be another thing you need to know. And DMR repeaters use color codes, much like analog repeaters are going to use your CT, CSS, or your PL codes. And that's used to sort of minimize interference. There's a total of 15 different color codes. Color code 0, is the equivalent to open carrier or open squelch.
Mike, do the color codes go by the name of the color or by the number of?
You know what? I was searching online and I could not find a corresponding color to the number. So it just goes by
numbers.
It just goes by number.
Okay.
Usually, most common you'll find most repeaters are using either color code 1 or color code 9. But yeah, there's no colors like blue, green, red, or aquamarine, which would be kind of neat. So when you're ready to program, everything kind of goes into your code plug. Code plug is an old term from commercial radios, and basically what that is nothing more than the programming file you send to the radio. Now the deal with DMR radios is that you can program them from the keyboard, but much like a Baofeng, it's insanely difficult. In fact, it's more difficult. And it's highly recommended that you use, they come with their own software program so that you can punch in the frequencies and you can assign the talk groups. And then that created file is your code plug that's then written to the radio. And this is probably the part, and then the radio software, you might hear referenced as the CPS, which in Motorola terms is the customer programming software. Or you might see it as computer programming software or code plug programming software. But since Motorola's got their hand in this, you get those funny Motorola terms. And this is probably the part about starting up with DMR that I think a lot of people get stuck on is creating those code plugs. It's best if you're wanting to get started in that is to maybe find somebody else that's active in the area with DMR. Maybe they can share the code plug.
You've got his business card, right?
Yeah.
So.
Some radios, the code plugs are compatible, and some radios they aren't. What I've done when I started out though is, I had a Redavis radio, but I couldn't find a code plug for it. But I found a code plug for like a TYT, and I was able to, I just downloaded the TYT programming software, and then I looked it up on the screen, and then that made sense on the screen, so then I just took that information and put it in the other radios, and into the radio that I did have. So Some radios are compatible, some aren't. I wish there was a greater level of compatibility between the brands, because these radios, once you turn them on, they're really all the same hardware wise. I don't know. They all use the same chips. They all use the same circuit boards, so they all come out of. The cases look different, but I think they all come out of that same factory in China. Every other radio. Okay, moving on. Talking on the local repeaters is one thing, but the neat thing about DMR is you can talk, cross country or around the world, and that's through the use of our DMR networks. There's really 3 networks in existence, and I'm going to kind of move. This really got tiny, but I'm going to kind of move from the bottom up. The first DMR network was one called DMR Plus, and that sort of bridged Motorola repeaters and Hytera repeaters together. They partnered with another group called DMR Mark, which is the Motorola Amateur Radio Club out of Illinois, and they only bridged Motorola repeaters together. But when DMR Plus and DMR Mark sort of partnered, then that created more compatibility with non-Motorola repeaters and also with DMR Hotspots. But the big network that's out there and that most people are most enjoy is the Brandmeister network. And Brandmeister came out of Germany. And I think most of their they've got servers in the U.S. now and around the world, but they've got the largest number of active talk groups available. They'll bridge Motorola and non-Motorola repeaters into the network, and they've got wide support for hotspots, or MMDVMs, multi-mode digital voice modems. Equipment-wise, DMR handhelds, $75 and up. Some inexpensive ones, you can get under $100. I think that sweet spot is in the $150 to $225 range. You can get a really nice DMR handheld radio. Some of the brands: TYT, Anytone, Redivis, Connect Systems, Hytera, and then of course Motorola. And the Motorola brand, it would be Moto Turbo. If you hear talk of Moto Turbo radios, that's their DMR line. Most of the radios now, when they first came out, they were single band, but most of the new models now are dual band radios. So you've got VHF and UHF, and they all have analog support. So you can use them as you can use your DMR handheld also as an analog radio. Mobile radios, around $300 or so. More if you find a used Motorola. Connect Systems, Redivis, Motorola. TYT's got one also. And then there again, I think they run off that same chip, so the interface is very similar with the handheld radios. It's just got a higher power amplifier on it, and a form factor that's good for mobile. And then finally, your DMR hotspots. Cost is variable. They can range anywhere from $100 to about $250 or so. They're called, the hotspot is the multi-mode digital voice modem, or MMDVM. Plugs into the internet, and then it's got a little transceiver on the back, milliwatts, like 7 milliwatts, which is enough power to get around your house, around the block of your neighborhood. But it connects you via a DMR simplex frequency into any of the talk groups that are available. So I've got a hotspot in my house, and I can talk to the Wisconsin talk group. I can talk to Nationwide. I can talk, I can dial in any ones that I choose. And these hotspots actually are multi-mode. So they'll work with DMR. They'll work with D-Star, Fusion, P25, NXDN. All of those digital voice modes you can use with your hotspot. Just got to alter the programming a little bit. Yep.
So with a hotspot, Mike, can you, any mode you come in at, It converts it to DMR
No.
into the network?
No, it
or-
doesn't. If you come in, if your hotspot is configured for multi-modes, if you come at it with DMR, it's going to go into DMR talk groups. If you come into it with Fusion or D-Star, it's going to go into a D-Star group or a Fusion group.
But actually, OpenSpot and some of the others will transfer from DMR to Yaesu
Yeah.
System Fusion or vice versa.
Well, there are rooms that are bridged together, so that if you come in on the DMR side, you can bridge out to the Fusion side. So,
But I mean, that particular hotspot will allow you to come in on Yaesu System Fusion on the modem, where you've actually set the chat room and a DMR site.
I'm not sure if I'm not sure.
I guarantee you.
Will it?
Guarantee it does.
Okay.
Yep.
Okay.
It'll actually cross mode.
Then it's doing some extra work. So.
And the Pi-Star software does the same thing.
Yeah. Right now, I just have mine set up for DMR, so it's I'm not bridging into other rooms or anything like that, or talk groups. So the modems do have I guess a level of compatibility between the different modes. Okay, so we talked about all the great things about DMR, but now what are the downsides of it? Because there's always two edges of the sword, two sides of the coin. DMR is more complex than other amateur digital modes. You know, Fusion is really neat because you can plug in your call sign, and you're on digital. D-Star is pretty simple. You know, once you're registered into the D-Star system, it's a pretty simple process to get into those reflectors. DMR, you got to build that code plug, and you got to assign those talk groups and to the frequencies, and there's a little bit more of a learning curve, and that hurdle to overcome. But once you get over that, it's pretty similar to the other modes out there. And that's when my camera mysteriously quit. So I don't have all of my thoughts on the last slide of this presentation recorded for the video, but carrying on with the presentation. Now, the second disadvantage is it's difficult to dynamically join or monitor talk groups. To get into a talk group, you're going to need to have that programmed into your radio. So say if you've got a set of repeater channels, that repeater channel is going to have a different channel in your radio for each and every talk group that you want to interact with. So you're going to have that same repeater is going to have a channel for the local talk. It's going to have one for maybe the statewide talk group, the regional talk group, maybe the local 2 talk group, et cetera, et cetera. So in order to switch talk groups, you've got to physically change that frequency or change that channel on the radio and then transmit and to get into the talk group. Not quite so with the other modes, where it's easy as dynamically pressing a few buttons on the radio, and you're automatically taken into that reflector or room. That's one of the big problems with DMR. Now, radios like the iLens HD1 allow you to dynamically edit a channel, so you could, in essence, reprogram a talk group on the fly and get into it. But for the most part, your DMR handheld radios don't give you that functionality. Third up, the radio build quality is all over the spectrum. We've got a lot of Chinese producers building radios, and we've got the top-of-the-line manufacturers like Motorola and even Hytera building radios. So you're going to see different price points and different quality levels of DMR radios. Your radiodity is not going to be the same as your Moto Turbo, when it comes to quality. But for the most part, most of the DMR radios in that, like I said, that $150 to $225 range, really, they have a decent level of quality to them and are nice functional radios. But like I said, build quality still is going to be all over the spectrum. And finally, I think this is the biggest problem, and this is something that's prevalent in all digital modes, is we've got another digital mode to choose from, or as what I want to call it, the balkanization of VHF radio. If you're familiar with the topic of balkanization, it's a geopolitical term that describes what happens to, say, a country or a region that's split into a set of smaller countries or regions, and each of those small countries and regions don't like each other. So you end up with your own little walled gardens where nobody's talking to anybody else. And we're seeing that same thing in amateur radio. You got the analog repeater, you got the D-Star repeater, you got the Fusion repeater, you got the DMR repeater. Everybody's sprinkled around on all of those other repeaters and enjoying those digital modes, but nobody is talking to each other. So driving into an area, you hear, oh, there's nobody on the repeater. Well, yeah, they're probably on a repeater somewhere, but they're not on the repeater that you're listening to. Hence the balkanization of amateur radio. And that's something I might do a complete video on that topic. But for that, that's the end of my rant. Well, that's it for my presentation on DMR. Do you have any questions or comments? Please leave those below. I'll pick out some of the best ones and highlight them in my next Your Questions Answered video. For more articles and information, be sure to check out my blog at www.jpol-antenna.com. Your support of this channel drives the production of future videos. So if you like this video, give me that big thumbs up, and don't forget to check out some of the other videos that are recommended alongside me here. And hit that subscribe button. Hitting subscribe will notify you when future videos are released. Well, that's it for this time. I'm Michael, KB9VBR. Have a great day, and 73.